All right, y'all. Today we're going to be talking about the unit circle. The unit circle is going to be an absolutely essential piece of learning for everything we're going to do here in Unit 3 in pre-calculus and as we move up through calculus and up in higher level mathematics. And it's one thing to learn the unit circle. Eventually, we're going to get to the point where the expectation is going to be that you can reproduce it and that you can memorize it. But I find that can be pretty challenging if I just tell you what the unit circle is as opposed to actually showing you and building that unit circle from scratch. So we're going to kind of build up from concepts and concept that we know in previous math classes to actually build and create the unit circle from scratch. So we're going to start with some triangles, and not just any kinds of triangles, but specifically right triangles, and right triangles that are our special right triangles. And the first one we're going to look at is our 45-degree or pi over 4 right triangle, which is one of our special right triangles of 45, 45, 90-degree right triangle. And what we know about this 45, 45, 90-degree triangle is that if its 45-degree sides or its legs are equal to a value of x, then we know that the hypotenuse is always equal to x times the square root of 2. And for the sake of our triangle, for the sake of our experiment, we're going to state that the hypotenuse is 1. So if that hypotenuse is 1, we can use this ratio because we know 1 is equal to x. Or sorry, not that 1 is equal to x. We know that 1 is equal to the hypotenuse, and the hypotenuse is equal to x root 2. So we can set an equation up. 1 equals x root 2. And then we can solve for x by dividing by root 2, which gives us 1 over root 2 is equal to x. But we don't love that. We don't love that radicals in the bottom. So we can multiply by root 2, multiply by root 2. We get x is equal to root 2 divided by 2. So we get that rationalized solution. So it's a little gross, but it gives us a side length of 1 for our hypotenuse and root 2 over 2 and root 2 over 2 for those sides. And of course, our hypotenuse is across from our 90-degree angle. And while degrees is what we're comfortable with when it comes to our special right triangles, we want to use radians because that's what we're upgrading to in AP Pre-Calculus. So pi over 4, pi over 4, and 90 degrees, it's going to be double of 45, so 2 pi over 4 or pi over 2. And I'm going to go ahead and add these onto our triangle. So we have root 2 over 2, root 2 over 2, and just because we might be using these or thinking about them later, I'm going to add this to be pi over 4 for our angles. Okay, so that's our 45-degree triangle. It's the first triangle we're going to use today, but it's not the only one. Okay, we also have our 30-degree or pi over 6 triangle. So our 30-degree triangle is another one of our special right triangles. So once again, with that right angle, but now our 30-degree triangle, which means that our other angle is 60 degrees. And if we remember, for our 30, 60, 90-degree triangle, which of course would be pi over 6, because it is 1/12 of 2 pi, or pi over 6, pi over 3 for 60 degrees, because that'd be 2 pi over 6, and then once again, pi over 2 for 90 degrees. That ratio is that whatever my shortest leg is, if I call that x, then my longer leg is x root 3, and my hypotenuse is always 2x. Now, just like we did before for our pi over 4 triangle, we're going to state that our hypotenuse is 1. This might seem arbitrary, but there's a reason why we're doing this. So if my hypotenuse is 1, then using my equations once again, we can say that 1 is equal to 2x, which dividing by 2 would give us an x value of 1/2. And likewise, if our longer side is x root 3, then we can do root 3 times 1/2, which gives us root 3 over 2. So over here in our side lengths, 1/2 for x, root 3 divided by 2 for our longer leg, and 1 for our hypotenuse. And once again, we can go ahead and add those on here. So our longer leg is across from 60, so square root of 3 divided by 2. Shorter leg is here across from 30, so 1/2. And then I'm going to go ahead and change these angle measures once again to be pi over 6 for 30 degrees and pi over 3 for 6 degrees, which is weird. It's weird that pi over 6 goes with 30 and pi over 3 goes with 60, especially because pi over 4 and 45, it just feels so nice. But it's just how those fractions work. Pi over 3 is obviously a bigger number than pi over 6. Pi over 6 is a smaller fraction, which is why it fits with our 30 degrees. Okay, now you might notice that we have this 60-degree triangle or pi over 3 triangle. But when you think about that, you might also notice that we already have a triangle with pi over 3. And that's correct. Our pi over 3, or our last triangle that we're going to look at, is actually identical to our pi over 6 or 30-degree triangle. So we can just repeat all of those same values. So our angles, of course, would be 30 degrees, 60 degrees, 90 degrees. Our radians would be pi over 6, pi over 3, pi over 2, and that ratio once again would be x root 3, and 2x for side lengths of 1/2, root 3 over 2, and 1, which you might think, Mr. Arbone, that seems a little crazy. Like, why would we do this twice? But there's a reason. There's a rhyme and a reason to what we're doing. So just trust me for right now on why we would actually do this. Okay, so we should now have these three special right triangles, all with that hypotenuse of 1. And using those ratios that we know, we've solved for those additional sides. So we're going to take those same side lengths, those same angles that we just found, and we are going to put them over onto these triangles, and you're going to cut them out. I know I'm not going to cut them out, but you're going to cut them out, and we're going to use them to start to build our triangle. So this first one we can tell is our 30, 60, 90. Now I'm only going to label it on one side, but I would like you to label it on both sides. So pi over 6, pi over 3, 90, 1, root 3 over 2, and 1/2. So like I said, I'm labeling on one side with my pi over 6 or 30-degree angle measures, but I want you to label it on the other side. So you have kind of a double-sided triangle here. And we're going to do the same thing for pi over 4. Once again, I'm only labeling on one side, but I would like you to label it on both sides. Okay, and once you have them labeled, go ahead and cut out both of these triangles, and we're going to use them now to build our unit circle. So you might have been eyeing up here in the top right that we have this quadrant 1 of the unit circle just sitting here. Okay, and this quadrant 1 of the unit circle is the same size as a normal unit circle, although my arc might not be perfect. I had to do it from scratch. I didn't actually measure it on a computer. But you should be able to take those cut out triangles and you'll see that they will actually fit on this quadrant 1 of the unit circle. So the first one we're going to do is we're going to do our pi over 4 triangle. And you should see that pi over 4 triangle, if you stick that pi over 4 angle in the corner, you should be able to fit it just like I am here. And I would like you to actually trace, so once you fit it in this unit circle, go ahead and actually trace these triangles here. That's why I'm drawing them again. And we're going to kind of add in some of those measures because this is the same triangle that we have cut out. We are just now putting it on a circle as opposed to as that floating kind of triangle. So this is, of course, pi over 4. And those measures of those sides, this bottom side here in the x direction, that is root 2 over 2. And this tall side here in the y direction, that is root 2 over 2. So if I were to actually list this as a point, then it is root 2 over 2, comma root 2 over 2. So these x and y distances that we measured out, that we found through our special right triangles, we can see that if we stick this on a circle, and when I say quadrant 1 of the unit circle, I mean the unit circle on the coordinate grid. So if I actually took this and stuck it on the coordinate grid, these triangles would fit and would actually measure root 2 over 2 in the x direction, root 2 over 2 in the y direction from that same triangle that we used. Okay, now we're going to apply the same idea. We did our pi over 4 triangle first, but now we're going to do our pi over 6 triangle. So same thing, grab your pi over 6 triangle. You're going to actually place it. I'm going to measure because I have a handy dandy measuring tool. And once again, we should see that our triangle fits. This is our pi over 6 triangle, and our point for our pi over 6 triangle was root 3 over 2 and 1/2 for those measurements, root 3 over 2 in the x direction, 1/2 in the y direction. And then the very last triangle that we're going to do is, it's that same triangle, but remember I told you to label it with the other measures on the back. So we're going to kind of reflect it over so that now the pi over 3 angle measure is in the corner. And then once you do that, go ahead and trace it. And this would give us our final triangle, which is at an angle of pi over 3 and with a point of 1/2 root 3 over 2. So these points are not coming out of nowhere. They are the x and y distance of those triangles that we solved for using our special right triangle ratios. So all of these hypotenuses of all of these triangles are 1, and then those side measures are those exact side measures that we calculated from the special right triangles. And I'm going to add in just a little bit of an extra piece, because remember, this is existing in quadrant 1. This is on the coordinate plane. These are real points on our coordinate grid. And so this point right here, this would be right along my x-axis. So it would be an angle measure of theta, because these are that terminal ray that we talked about. So if our terminal ray is at the same spot of our initial ray, we don't have any angle measure, so 0. And that point would be 1, 0, because I've gone exactly 1, that radius of 1, just like my hypothesis of 1, in the x direction. And at the same idea, I'm going to add another point up here. But this isn't going to be 0. This is going to be a quarter of a circle, or pi over 2. And my point for this one would be 0, 1, because I've now gone 1 up in the y direction. And this is quadrant 1 of the unit circle. And the reason why quadrant 1 of the unit circle is so important is because if we know quadrant 1 of the unit circle, we actually know the whole unit circle. And we're going to see how this works here in just a second. So go ahead and grab your blank unit circle. We are ready to take this information and actually produce a unit circle from scratch. So looking at our unit circle, you'll notice our quadrant 1 looks very similar to the one we just produced, although this one's actually symmetrical. Mine on the notes is not perfect, you might notice, but semantics. And so let's go ahead and add in the information that we just added in for our quadrant 1. So I'm going to add in those quadrantal angles, which, yes, these angles here on the axes are called quadrantals because they happen in the quads, or every fourth of the circle. So our radian measure of 0, which gives us a point of 1, 0. Our radian measure of pi over 2, which gives us a measure of, or a point of 0, 1. And you might notice there's a spot on this unit circle for degrees. If you want to add in degrees for your understanding, that's totally fine. but I'm never going to talk about degrees. Remember, AP Pre-Cal, we've moved on. It's only radians. So I want you to start thinking in radians. So if you want to kind of test yourself there, you can, so that you're kind of moving in that radians direction. Okay. And then we're going to add on our other triangles. So pi over 4 was, of course, our middle triangle, and that was root 2 over 2, root 2 over 2. Then pi over 6, this is our smallest angle measure, root 3 over 2, 1/2. And then, of course, pi over 3, which is 1/2 root 3 over 2. So all I've done is I've transferred over what we discovered over on our notes here, and I've now transferred it over to our official unit circle. All we're doing here, nothing too crazy. Okay, now this is the part that gets really cool, and this is also why we have those cutout triangles, because what I want you to do is we're going to use those triangles to see that they don't only apply in quadrant 1, but they apply in quadrant 2, 3, and 4. But I'm going to start off, but I'm going to add in our quadrantal angles, because remember, our quadrantal angles are in quads. They are a fourth of a circle. So our very first one here was 0, because this is no angle measure. Then I went 1/4 of a circle, which got me to pi over 2. Then 2/4, or half of a circle, which would be half of 2 pi, because 2 pi is my whole way around, or of course pi. And then over here, instead of going 1 in the positive x direction, I've now gone 1 in the negative x direction. So this would be negative 1 over 0. Now this next one's going to be a little wonky. So remember, 0, 1 pi over 2, 2 pi over 2, which is pi. So that would make this 3 pi over 2. And then this point, instead of 0, 1, because I've gone positive in the y direction, this would be 0, negative 1. And now those quadrantal angles might have already given you some hints, because you might have noticed, oh wait, as we moved around my coordinate grid, the signs of some of my values change. And so that's really important. So let's start with our 45, or our pi over 4 angle. So here in quadrant 1, you can grab your pi over 4 triangle. It was pi over 4, and it was positive root 2 over 2 and positive root 2 over 2. But if I take that triangle and I reflect it across the y-axis over here, it's still a pi over 4 triangle. So this radian measure right here should be something over 4. But this was 1 pi over 4, 2 pi over 4. So this is 3 pi over 4. Remember our angles that we did last class? We can count it in pieces of pi. And then my point, still root 2 over 2 and root 2 over 2, except in quadrant 2, my x values, just like my point here on the quadrantal, are negative. So this is now negative root 2 over 2, root 2 over 2. Okay? And from there, if I wanted to, I could reflect it again. I could take this triangle and I could reflect it across the x-axis down here into quadrant 3. And quadrant 3 is now 1 pi over 4, 2 pi over 4, or pi over 2, 3 pi over 4, or 4 pi over 4, which is pi, which would make this 5 pi over 4. So the nice thing about radians, y'all, is it's really just a counting game. You don't have to do crazy fraction addition or anything like that. You can just count the pieces of our pi. Okay, so 5 pi over 4, and then I've taken this point, negative root 2 over 2, and I reflected it across. So my x values are still negative down here in quadrant 3, so negative root 2 over 2. But now my y values are also negative, negative root 2 over 2. And then I can take this same triangle now and I can reflect it one more time back across the y-axis. This time my x values are going to go from negative to positive, but my y values are going to stay negative. So my new point here would be positive root 2 over 2, negative root 2 over 2. So you should notice all 4 of these points have the same numerical value, but different sides depending on which quadrant they're in. And then, of course, for my radian, 1 pi over 4, 2 pi over 4, or pi over 2, 3 pi over 4, 4 pi over 4, or pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2, which then makes this 7 pi over 4. Okay, and I'm going to show you, hopefully that kind of started to connect. You're like, oh, Mr. Arbonne, this is starting to make sense. The triangles, I can use them across the circle. Okay, but I'm going to show you one more reflection so we can see that this still holds true no matter what our triangles are. So let's take our pi over 6 triangle once again. Take that pi over 6 triangle, stick it here on our unit circle. We can see that it makes pi over 6, x direction root 3 over 2, y direction 1/2. If I reflect that triangle across my unit circle, my new point, negative x value, so this would be negative root 3 over 2, but still positive y value, so still positive 1/2. And then for my angles, so when I did my pi over 4, notice it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So my circle was split into 8ths. For my pi over 6s, it's 1, and I'm going to skip pi over 4 and go to pi over 3, 2, then pi over 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 slices of pie because I skip the over 4s. It's like I have 2 pies going on. I have a pie split into 8ths and I have a pie split into 12ths. So for our pi over 6s, I have 1 pi over 6, then 2 pi over 6, which is pi over 3, 3 pi over 6, 4 pi over 6, which we'll come back to later, but we're going to leave it blank for right now. And then right here at my new triangle, this would be 5 pi over 6. Okay, so hopefully you're starting to pick up on the patterns. And what I want you to do is I want you to use those triangles to see if you can fill in the remaining points and the remaining radians. Okay, and then once you do, see if you can come back and you can draw some conclusions about positive and negative values on our unit circle. So go ahead and pause the video, and then I want you to try and fill out the rest of this unit circle on your own to the best of your ability. If you don't feel confident, you can, of course, unpause and just copy down the unit circle. But try and create this as much as you can on your own. Because like I said, if you build it and you create it from scratch, it's going to connect a lot better when you get to that memorization phase. All right, y'all. And here we can see that completed unit circle. We can see those connections where all of our pi over 6s, so pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. See how they all connect? They're that pi over 6 triangle. Our pi over 4s all connect. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And then our pi over 3s, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So we're getting those connections. We're seeing those pieces, how those triangles have the same side measures, same lengths for x and y. It's just switching as we switch quadrants, the signs of those x and y values. So the point stays exactly the same in every quadrant except the sign changes. That's the key of the unit circle. So that's why we say that if you know quadrant 1 and you know the relationships of each quadrant, so quadrant 2, positive y, negative x, quadrant 3, negative x and y, and quadrant 4, positive x, negative y, then you can reproduce the unit circle from scratch. So as long as you know quadrant 1, you know all of the quadrants because you can reproduce them. Okay? So that's the unit circle, y'all. You know it. You understand the unit circle. You know where the unit circle came from. Now comes the hard part, which is memorizing or being able to reproduce the unit circle. Now, like I said, it comes from special right triangles. So if you can reproduce the special right triangles with the hypotenuse of 1, you can always build the unit circle again from scratch. That's totally fine. Okay? Or if you can at least, like I said, memorize quadrant 1, then you can always reproduce quadrants 2, 3, or 4 from quadrant 1. Now, if you're just like, Mr. Arbone, I just want to be able to bust the whole thing out. I don't want to worry so much about building everything from scratch. That's also okay. If you need to fully produce the unit circle from memory, that's fantastic. That's still going to show that you understand that unit circle. Okay, so practice makes perfect when it comes to the unit circle. So these are our notes that you picked up. You should have also picked up a blank unit circle practice. Obviously, if you write on that with pencil, it will be completed and done. So what I recommend is that you take that practice and you stick it in those blank communicator boards, or you can stick it in like clear pocket protectors, and you can write on them with Expo markers and then erase, so you can constantly practice producing that unit circle over and over and over again. And when I see you in class next time, or I see you in tutorials, come and ask me about some tips and tricks for memorizing the unit circle, because I got some fun ones that can help you with some deeper connections. But that's all for the unit circle, y'all.